Hey YouTube, this is Maxwell and welcome back to Animating Physics with Python. This is part 2 of the Projectile Motion series where I animate a simple case of projectile motion, or projectile motion in just a simple case. In this part we will begin coding, but I want to preface this by saying this is not an in-depth tutorial on tkinter or Python. This is more for those who are familiar with tkinter, or at least programming, familiar with Python, and may want to see how you would approach creating an animation like this on something like projectile motion. And so with that out the way, we'll start coding, but first I want to show what we'll have done by the end of this video. And it's just this simple scene. Where'd my floor go? Okay. So we'll have this canvas that takes up 80% of the screen. It will have like a sky blue background, this brownish floor, and a red ball, which will end up moving in later videos. This bottom part, we have this thing like calling a configurations frame, which is a frame that will hold these spin boxes that will allow the user to set initial velocity and an angle, and the start animation button. And so this is what will be created by the end of the day. So to start, we'll create a package, and to do that we create a directory. We'll call the directory Projectile Motion, and I will open it. So you can exit out of this. And so first we'll create init.py, which makes Python recognize this directory as a package. And now we are on to 4 other modules we're going to create. So the 4 modules we're going to create are animation.py, which will handle the canvas and drawing the animation. So module that handles canvas and drawing the animation. Next is configs.py, which will handle collecting the projectile motion variables from the user. Module that handles collecting projectile motion variables from the user. Next is window.py, which will handle the application window and adding the canvas and configurations frame to it. Handles the application window. And last but not least is main.py, which will be our entry point into our application and kickstarts everything. And so to start, we will create our window just for some instant gratification, see something on the screen quickly. And we'll start off with main.py, and we'll create import tk. This tk is the window widget, and basically allows us to start off everything. If main equals main, we'll create our window widget and set it rolling, our main loop. This is why main.py is our entry point, because it calls this main loop function and actually starts our GUI application. So in window.py, we will create a class called window, and it will actually take in that window widget tk, and we're going to do some stuff with it. So first we're going to set it as an attribute, and next we're going to give it a title and make it full screen. To do that, we'll call this title function and write anything we want. We'll call it projectile motion. And to make it full screen, I'll collect the width and height of our screen with this function called winfo screen height and screen width. This will be height. This other one should be width. And we'll make this compliant to pt.8. I like code's gotta look good too as well. And we'll add that, we'll set it to our geometry. So root geometry f of x sc width sc height. So now we've made our window full screen, we'll import our window class and call it. Give it root. And now we should end up with a beautiful full screen window widget called Projectile Motion. So Projectile Motion and full screen, we just have to do a little bit of mouse moving to actually clip it into the whole screen. So now that we have that, we will start with the canvas, and actually not that. First we need to set up the grid. And so the grid isn't much, it will just be 2 rows, and the top row will hold the canvas, the bottom row will hold the configurations frame. Obviously the top row will be bigger, so we'll have to set up the weights of these of the rows and grid. And there's just one column, and so we'll do that as well. So let's set up grid weights. Again, so like I said, the first row, the 0th row, will have a weight of 4. The second row will have a weight of 1. Just much space out back here. And our one and only column will have a weight of 1, but it really doesn't matter what we give it since it's the only column. And we give the top row a weight of 4 so that it grows. It takes more unused space than the bottom row, approximately 4 times more. And so when we add in our canvas to this top row and the configurations frame to the bottom row, there'll be a 4:1 ratio, giving like 80% canvas, 20% configurations frame. So now we've got the grid and weight set up. We'll go into our animation.py class and actually create our canvas that will hold, actually draw our animation. That we import star. We'll create a class called Projectile Motion Animation, since this will handle animation. It will inherit from canvas. We'll set up its initialization. And when we initialize it, we'll initialize it with a width of 1, a height of 1, and a background that is sky blue. For the configurations frame, we'll do the same thing, but this will be a frame, not a canvas. Okay. Class projectile motion config frame. And when we initialize it, this will have a width of 1, a height of 1, and because this frame is using the newer TTK styled widgets in tkinter, the way to set background color is different. We actually use this ttk.style.self configure and take keyframe, and we'll make this background pink. Yeah, why not pink? So now we've created our two widgets. We go back into window.py and we actually create those widgets. this. Great. And we will add them to the grid. The canvas will be top row, same column as anybody else, and we'll add the sticky parameter, which will make sure it will expand into its full cell. So it will even though we set its width and height to 1, this sticky parameter tells the widget to take all the space, expand into the entire cell, because we added every compass point. So that width height we set to 1 doesn't really matter. We set it to 1 so that there would be as much unused space as possible, so that when the weights kick in for the rows, because there's so much unused space, that 4:1 ratio will be pretty much exact. And so we'll do the same thing with the configurations. Row will be second row, same column, same thing with sticky, take up every single inch of space in that cell. And we'll run it and see if it works as expected. So I spell height wrong somewhere. Unknown option height, so it must be when I initialized it here, and here it is for height. Oh wait, do I not know how to spell height anymore? Where do I spell it here? HT. Here, TH. Yeah. Boom. So now you likely see we've got our sky blue canvas taking up about 80% of the screen, and our pink configurations frame taking up about 20%. There is this annoying border that comes with the canvas, and after some online searching, I figured out you can get rid of it using this highlight thickness variable parameter. We set it to 0. This line's getting a bit too long, so we'll get to another line. And so now we have set that to 0, no border, and it looks kind of pretty, not gonna lie. The pink actually goes well with it. But we're gonna get rid of the pink because it's not right now, but later. So now we have our canvas and configurations frame drawn into our window. We'll create the actual scene for the canvas. So we'll create a floor and we'll create our ball. So let's get to that. So we're already in our canvas class, and to do that, we'll create a function called setUpCanvas. And in this function, we'll call these a draw floor function and a draw ball. And we'll quickly create them, but not implement them. The first one we're going to implement is draw floor though. But I want to make sure they're there so we don't run into any errors. So pass, and with draw floor, first what we're going to do is get the width and height of our canvas. We'll call it WH. And because we are in the canvas class, the canvas is just self, and we can use our winfo functions to get the width and the height of our canvas. And now we're going to create an attribute called floor height, because we are going to want to know at all times where the top coordinate or the height coordinate for our floor is. And so we'll set it to the height of our canvas minus 10, so it'll be 10 above. And it's minus because if you already familiar with tkinter, the coordinate grid is 0, 0 at the top left corner. So the x variable goes the x variable works as normal. It will be 0 from left to right. It goes up, but in the y coordinate, so for our height, because the top left corner is 0, as you go down the screen, our height coordinate goes up. And so if you want to go up, as in towards the top of your screen, you have to lower the height coordinate towards 0. And so we minus 10 to bring it up 10 pixels from the bottom of the canvas, which will be height. And we actually create a rectangle, which will be our floor. So the first two numbers we're going to put in are the xy for the top left point of our rectangle. And so for our x, it will be 0. We're going to stay on the, because it's our word toward the top left point, we're going to be on the left edge of the canvas. And we're going to be, our height will be floor height, because we're top left. And then bottom right, our x variable, or our x component, will be all the way to the right edge of the canvas. So we'll set it to width, just the full width. And because we're at the bottom, we want to be at the bottom of the canvas. We'll set it to h. Now we'll give it a color. The color I picked out is Sienna 3 because it's a nice brown. And we'll set the fill does the inside, the outline makes sure the border is the same color. So it's all the same color. And make this pretty. I keep messing this up. And that should be our floor. So if I call this, actually first I do need to, we need to call setup canvas first. And the thing to remember is that because we have not started the main loop as we're doing all this code, the main loop has not started yet. And so before we call setup canvas in our window class, we need to make sure that all the canvas knows its height, knows its width, and it won't know all that until we call this update. We call update on our window widget, so that it kind of does all the processing to make sure the canvas knows its true height and true width. And now we can actually go to canvas and call setup canvas and trust that everything should work fine. Call pi.main.py, and boom, we've got our floor. It's at the bottom of the canvas and it's raised a little bit up, so you see our top left point is here, bottom right point is here, and it works as expected. We can exit out, and now we want to draw our ball. So now we can go to draw ball. We're gonna want the diameter, and we're gonna set it to 50. And we're gonna set an offset, and we'll see what the offset's for soon. And we need to create any sort of any sort of circle. You must use the self.create oval function in the canvas, and you put in coordinates for top left and bottom right square. So whatever you want your circle to be, pretend that you're making a square and set the coordinates for that square, and the canvas will make a circle within the square or rectangle you put in. And so to visualize this, we want our top left point, which will be the first two numbers we add in, to be a little bit off the left edge of the canvas, and the height of the ball up from the floor. So for our x, it will be equal to offset, because we want to be a little bit just off the left edge of our canvas. And its height will take the floor height. So right now, this is our top left point would be at the floor height, but now we want to minus the diameter of the ball. And that will bring it up all the way to where it should be. And now for the bottom right point of our square, it will be equal to the offset plus the diameter of the square. So imagine we go back to our offset and we add the diameter of our circle. It ends up being equal to the side of our square, which is the diameter, and it will be where we need to be. And our y point will just be the floor height. So Boom. And now we'll look at that. Now we've created this, we should be able to see. So actually I forgot to add a color, so this might not look good. Oh, I created something. So now we've got our ball. It's just a red outline. I mean, not a red, but black. But now we'll make it red so it's more noticeable. Fill equals red. And boom. So now we've got our red ball. And if you notice, it's actually digging into the floor a little bit by probably what looks like 1 pixel. And so we'll actually just take our y points and just -1, just 1, just to correct for that and make sure it's aligned. And great, now we're really just straight on top of that floor, and that looks almost at where we need to be. Last thing we need to do is actually add our widgets for this configurations frame, and to add the initial velocity, angle, and a button. And before we do that, we're going to need to know that it will end up being a grid. This frame will have its own grid that is 3 columns. So it'll be 1 column, 2 columns, 3 columns, and it will be 2 rows. And the top row will hold the label for the text saying, oh, this is initial velocity, this is angle, and for the button, it doesn't matter. And the bottom row will actually hold the spin box that will allow the user to place in whatever value they want for initial velocity or angle. So let's get to that. And they're all the same sizes relative to each other. So all the rows are the same size as other rows. All the columns are the same size as other columns. So all the weights will be equal to 1. Let's go to configs and let's set up the weights for those grid, for those things. Set up grid weights. Like I said, there are 2 rows, both same size. So we'll give them both a weight of 1. Then there'll be 3 columns. So 3 is enough that I'll use just a for loop. And say stuff.column configure I and weight is equal to 1. That sets up our weights for that, and we'll create a function called setup configs. So, and now first thing I'm going to do is create the spin box and label for the initial velocity. So get initial velocity. The attribute we're creating here called init velocity will hold an int var, and this int var will know what the user placed in for initial velocity, and so we're going to keep that as an attribute. But then for the label, we're actually drawing things into the window. This label, its master or its parent widget will be this frame, so self, and its text will be, this is initial velocity. Initial velocity. And in the grid will be the top row, the first column, and we'll stick it to the bottom edge of its cell, so south. We do almost the same thing, but here we'll use a spin box, and it will have no text. But the spin box, with a spin box, we can set caps on what the numbers we want to allow. So the lowest value we're going to allow is 0, and the biggest value will probably be 999. Doesn't really matter. And we'll stick it to the top of its cell. And this will make it so that the text saying initial velocity and the spin box that is actually allows the user to place the initial velocity are just super close to each other, and they look alright visually. Next, we do the angle. So again, we'll create an attribute. Oh, and I forgot, we need to set this text variable to self.init velocity, so that whenever the user places a value for initial velocity, it will go into this int var, and we can get it later. This line is too long, over 100 lines. We'll cut it off at here, text variable. The tabs. 86 is still too long for me. Oh, I know what to do. We'll cut it off at. You know what? It doesn't matter. We'll clean it up later. Focal angle. Int var again. This is almost the same thing. Its parent is this frame, but this text will be angle. And in the grid, again, it will be the top row, but this is the column next to it, so we're moving on from the column. And sticky, again, stick to the bottom part. And I just realized I said this is the same, so on row, and this is almost the same, so I'll just take this spin box, but this is the angle, so our maximum value will be 90 here. Our text variable will be the angle, self.angle int var. The row will be 1, column will be 1, sticky is n. And now for our button, start animation button, we'll just create a button. Okay, button, self, its text will be start animation. On the grid, it will be, let's say, top row, which is also the last column we have, and we'll stick it to the bottom of itself. And that should be good. So if we run this, well, actually, because this does not require us to know the size of the frame at any point, we can just call this immediately. So when this widget is created, when this widget is created, we'll just populate it immediately with these widgets. Boom! We've got the spin box, allows us to place a value. Angle, let's see, that's actually maxed out at 90. We got 89, 90, and does not have to go further, so that's cool. And that's our animation button. And really, the only difference from our preview is that this is pink, but you know what? I'll leave it pink. I like it, kind of. Yeah. Alright, so that's all for this video. We've got to this point, and now next video, we'll actually be able to use whatever the user places in for initial velocity and angle, and make this ball move. So, alright, see ya.